Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Arteris IP with Paul Graykowski, who's going to talk today about why engineers need traceability and what they can do with it. Paul, traceability has been around for years. Why do engineers suddenly need it?
So traceability is becoming really important for the semiconductor side of the design cycle. What we're finding is that we have issues with tracking requirements, and ultimately the artifacts that relate to those requirements can change downstream. When that happens, we have to be able to detect it and react to it appropriately.
Let's dig into this.
Sure.
Paul, what are we looking at?
So what I have here is a diagram of a typical semiconductor life cycle and all of the aspects that follow along with that life cycle. So we have requirements that we have to track. We have various specs that relate to those requirements and all the design features. We have the design data itself, which is typically represented in IP exact. And then we have all the verification components. Now this is a simplified diagram. It doesn't go into all of the details that we normally track, but these are the key ones that we have to track, and we have to keep watch over this through that cycle for the semiconductor. So everything that we're doing here is we might have links to these different aspects. We also have to have checks in place. So we have to know if something changes downstream, does it ultimately reflect on that requirement that we started with?
How do you know if all your requirements are being tracked?
Yeah, that's not always an easy answer, because what we have to do is ultimately tie all of the requirements that have been dictated by marketing, sales, etc., the customers, and we have to make sure every one of those is linked to its various artifacts. Artifact might be something like a specification, might be in Digit, could be in Word. It also could be a design aspect. So how does that design connect into the system? What is its system map? All of those aspects. And then ultimately even the verification of that. How do we know that we truly implemented what was specified up here in the requirement? So we have to have these links to all of this, and we have to make sure all of these are checked.
And those requirements may change by the time you get your design out the door too, right?
Definitely. That quite often happens. You know, somebody might change a requirement, customer comes in at the last minute and says, hey, I need this feature instead. Now, that ultimately impacts all of these aspects. So we have to make sure these are connected. We have to make sure that we have a process in place to verify all of these things that they changed appropriately as per the requirement, and that we keep track of that.
The way that this has been dealt with in the past is people would build one product for multiple markets. They'd make it almost bulletproof, whatever requirements are the most stringent, but that's not necessarily the most efficient and the fastest way to get to market, right?
No, it definitely isn't. You know, things are always changing. That's the dynamics of building a semiconductor today. Everything changes, and everybody wants something custom, and we have to react to that quickly. And the problem with this always is down the line that, you know, maybe somebody forgot to mention to the right person that a feature has changed. And how do we provide automation for this to make sure that if something changes, we actually recognize it and can react to it appropriately?
So you're getting much more granular with the requirements and the specifications and the design too, right?
Definitely. So what we're doing is we want to make sure that every requirement ultimately links to a particular artifact. An artifact could be any number of things. It might be the actual HDL that was coded. It might be the test that verifies that feature was done. It might be a JIRA ticket that actually specified how it was going to be done, or maybe there was a bug reported during the verification process. We have to make sure all of that follows through and connects together.
So if you're an engineer working on a design and you're checking all the different pieces that are going in there, how do you know there isn't a gap?
Yeah, that's a tough one to do in a traditional system because it's a very manual process. You're relying on, you know, an architect to give the information to the designer that it's all specified and everything is connected all the way back to requirement. That doesn't always happen. So you want a system that leverages across all of your different systems, that, you know, your requirements specification system, your specification system itself, and all of your design flow. And you need to make sure those are connected and interconnected together and work properly so that you can see this information.
Does this become harder as designs become more heterogeneous? So basically you're developing this in many different places. You have different kinds of teams. One of the teams may not even be part of your operation, right?
Definitely, that happens a lot as well. You could have distributed teams across, global teams, remote workers, all of that ties together. So they have to be interconnected. You can't rely on everyone sitting in a room and kind of chatting about, hey, this is the core team, here's all the features, we're going to do this. It doesn't work anymore. It has to be tracked back to something that's in a computer system and linked together.
So you think about engineers sitting down in a conference room doing a design review. What changes here?
So for the most part, the overall flow is the same. So what we want to do is utilize the best tool for the job. Those tools are already in place. It might be something like IBM Doors for entering requirements. Might be, one of the big three EDA companies using their simulators. All those different aspects, they stay the same. What you really want to do is bring together a system that pulls all that together and still lets you use those tools and just kind of takes those disparate systems and makes it a single system. And then you're good to go.
What have people been doing up till now?
Up to now, it's all manual. It's really everything about either manually converting or interpreting and developing new tools, maybe even building scripts to connect things together. It's really an ad hoc solution all over the place. It could be anything.
One of the other challenges here is that you now have new certifications coming in. You've got certifications in all the safety critical applications, like all the ISO certifications. What changes there?
Yeah, so that's also a very big question, and it can be very painful for the existing teams to deal with. So what you want to be able to do is be always ready for an audit, so to speak. So if you have a system that brings all these separate systems together, as we're showing here, what ends up happening is all of the information is contained within it. So we have the history of changes, why things were changed, whether they were allowed to be changed or not. We have everyone being informed across the board of what's happening. So not only that, what's really important is we have a reporting mechanism. So we want to be able to take the information that's in this database from all these systems and be able to output it. That gives you a report in your hands that you can go to your safety certification audit with, hand it over, and everything's documented. Memory map, the feature set, the full documentation flow is there for you.
So you've got three elements here, one of which is certification, which we just talked about. The other two are change management and revision control. Is that correct?
Right, that's correct. So those are very important aspects as well. So we have changes could happen, whether maybe it happened down in design. Maybe something was discovered that it was not possible to do to meet a timing spec, for instance. And to do that, design may be impacted so that you can get the timing back there. So to do that, you have to go back to the requirements and make sure that you're still in sync. Now, at the same time, you also have design data that could be undergoing revisions. So you have multiple engineers working on it. They check in different versions of the files. What if something changes? We need to be able to track that as well and tie all that together.
And the goal here is to have both reliability as well as when you get through, you don't have to do all these checks a second and third time, right?
Definitely. What we want to be able to do is have an active system of monitoring. Basically, checks are in place at all the time so that if something happens, we know pretty much immediately, real time, what changed. And we can actually act on that change now. And maybe we need to go back and change the requirement. We want to be able to change that quickly because maybe this impacts something we committed to the customer. We need to fix that. If we get to the end of a project and we're doing our due diligence and checking everything off at that point, it's really too late. You don't want to respin a chip because maybe a design change is impacting your requirements.
Does this improve time to market overall?
Definitely. It forces a more rigorous approach where you're going to be really tracking everything, but at the same point you don't want to add a lot of overhead to what you're doing, so it's just going to kind of streamline your process, and it enables you to react quickly. So when things happen, you can react, and that's ultimately going to shorten your cycle because at the end you don't want to be changing everything and going back and having to reduce features and etc.
Paul Graykowski, thanks for a great explanation.
Thank you very much, Ed. I appreciate it.